Okay, today we're going to talk about trig identities. Trig identities are difficult because there's multiple ways to approach a problem. And in fact, there's many times when you go through a problem that there are four or five or more correct approaches. What I'm going to try to do here is try to streamline our approaches. And we're going to start with this little diagram right here. So what we're talking about in this situation is limiting our process to just these three aspects. So every step along our process, we're going to do one of these three things. We're going to change every aspect of our identity to sine or cosine, or we're going to apply an identity that we already are aware of. Second, we could apply the Pythagorean identity, and that's where this little 2 comes in. If we see a squared term, then we're inclined to look for the Pythagorean identity. And third, we're going to apply basic algebra, that is adding, subtracting, multiplying, or dividing, or factoring, or maybe distribution. There's no right or wrong order for each of these, but every step along the way, we're going to refer to these three possible steps. Okay, we're going to start with example 1. Example 1, tan x times the quantity cosecant x minus sine x equals cosine. And we have our diagram here that is still something we're going to be able to refer to. Okay, so we're going to look over here. We have no squared terms, so we're not going to look at the Pythagorean identity. Even though there's possible multiplication here with tangent times this parentheses, that's a difficult multiplication to perform, so we're going to leave the algebra alone, and we're going to go to changing everything to its sine cosine equivalent. Now you need to remember your rules for sure, but in this case, we're just going to apply our basic identities to this particular problem. So we're going to change tangent to its equivalent, sine x over cosine x. We're going to change cosecant to its equivalent, 1 over sine x. We're going to leave sine of x alone. And because our right side is so simple to begin with, we're going to leave this alone for the duration. So that's our goal at the end of this whole thing, this cosine x. So now we again look at our situation and we look to apply one of these three steps. Once again, there's no squared term. We've already applied our sine or cosine. So now we're going to apply our algebra. And in this case, we're going to distribute this throughout. So we're going to multiply the fraction sine of x times sine of x over cosine x times 1 over sine x. When we multiply this through, we notice we have a sine over sine, so that immediately cancels, but I'm going to write that out anyway. So our new fraction is sine x, that's sine times 1, over cosine x sine x. And then we distribute again, and we're multiplying it by negative sine x. We could think of that as sine over 1 if we want, and this becomes negative sine squared x all over cosine x. At this point, we've just distributed. Maybe we could do simplifying beforehand, but we're going to distribute in this case. And now we're going to look at each fraction individually to simplify if we can. We have a sine over cosine sine here. So we're just going to cancel those signs. And remember, we're not left with 0 up top. We're left with 1. So we have 1 over cosine x times sine squared over cosine x. And once again, like every step along the way, we are going to look back to our three aspects. Yes, we have a squared term here, so there's a possible Pythagorean, but we're going to leave that alone. We notice we have a common denominator here, so we can combine these fractions using algebra. And we're left with 1 minus sine squared x over cosine x. At this point, we look again at our three rules, Pythagorean, sine, cosine, and algebra. We've done all the algebra we can do. We've done all the sine, cosine we can do. So we're going to apply our Pythagorean identities. And we recognize that 1 minus sine squared is actually equivalent to cosine squared. So we're going to change this numerator to cosine squared. Our denominator remains the same. And then our final step is going to be to apply the algebra. Cosine squared over cosine reduces to simply cosine x. And that was our goal. So that's the first example. Okay? Now, in that case, it worked out pretty easily, but the fact of the matter is, all we did along the way was apply our rules as we went. So here we are for our second example. Again, the same idea, the same reference. We have 1 minus cosine x quantity times the quantity of 1 plus cosine x, all equal to sine squared x. Once again, we have one side that is essentially simplified. So we're going to leave this as it is, and that's going to be our goal. We look back at the left-hand side. We can't change to sine and cosine, obviously. There's no squared term, so we're not going to deal with Pythagorean. We're going to apply our algebra, and we're going to use FOIL here. So we do 1 times 1, which gives us 1. We do our outer 1 times positive cosine gives us a positive cosine x. Our inner negative cosine times positive 1 is negative cosine x. And our last negative cosine times cosine is a negative cosine squared x. Basic algebra, cosine minus cosine, and we're left with 1 minus cosine x, or cosine squared x. We look at what our goal is at this point, which is sine squared, and in this case, this is in fact an identity. This is a Pythagorean identity where 1 minus cosine squared is in fact sine squared x, and we are done. We've accomplished. So again, we just followed the basic rules. Maybe we could see this before it happened, but the only thing available to us initially was our algebra. All right, third and final example. This is a little more involved. Okay, example 3 we have here. We have our, let's get rid of this line right here. Boom, boom. Okay, so we have 1 minus cosine squared over 1 minus sine is equal to negative sine x. Once again, we are going to leave the right-hand side alone. We don't have to. Some kids are under the misconception that we can't do anything to one side, we only have to do one side, but in this case, we're just leaving it alone because that's a simplified form. So we look at the 3 choices here: Pythagorean identity, sine, cosine, and algebra. Well, it's already in sine cosine, so that's not going to be a concern. Pythagorean identity is an attractive option here because what we're looking at has not only a cosine squared up top, but also has a 1 minus sine at the bottom. So there's a possibility that that might work. If we performed algebra, we would just change this 1 to an equivalent 1 minus sine over 1 minus sine to combine these. But that doesn't seem like that's going to be the cleanest option. So what I'm going to do here is I'm going to apply the Pythagorean identity to just this cosine squared. So I'm going to end up with 1 minus, and then this cosine squared becomes 1 minus sine squared x all over 1 minus sine x, no squared, and again we leave this right-hand side alone. So we performed our Pythagorean identity. At this point, there's going to be some experience that plays a part here, but the fact of the matter is we really need to recognize this for what it is, which is the difference of 2 squares, which brings us back to our algebra. So I'm going to factor this numerator in the difference of 2 squares, and what's going to happen is going to fall right into place. So my 1 remains the same. This numerator becomes 1 minus sine x times 1 plus sine x, all over remaining to be 1 minus sine x. So this move, first of all, I applied the Pythagorean identity here to 1 minus sine squared x. This recognition is going to be something that becomes more comfortable the more you do it, because there's going to be frequent opportunities for you to make this particular factoring job. So at this point, we have 1 minus sine x, 1 plus cosine x, all over 1 minus, and these two just cancel. Now this minus sign, I need to be careful here. This minus sign is addressing this entire numerator. So I'm going to push that minus sign through, and it's going to become 1 minus sine x. Well, 1 minus 1 is 0, and this whole thing becomes minus sine x. And as often happens, sort of out of the blue, we come up to our solution. So our process for all of this situation is simply to address these 3 steps every step along the way and to apply them accordingly. Really not necessarily knowing where we're going, but if we apply these appropriately, we'll get to where we need to go. And as I said earlier, even though we didn't change this to 1 minus sine, we could have changed that to 1 minus sine if we wanted, and still arrived at the right answer, but probably with a little more algebra and a little more complication.